All right, in part two, now we are going to be looking at the union and intersection of sets. And we talked briefly in part one about the union and intersection of sets, what that means. Again, union is combining all the elements from multiple sets together. So the example I gave in part one was if I have a room of people and I'm looking at the set of people who are wearing red and the set of people who have brown hair. If I want the union of those two sets, that would just be bringing everybody who has either brown hair or is wearing red and bringing them all together. The intersection of those two sets would be what the two sets have in common. So that would be all of the people who are wearing red who also have brown hair. They have to have both of those things. So we're going to be applying that to now sets of numbers. We're going to look at first two sets written in roster method. That's just listing out the elements in the set. And then we're going to be looking at some sets in what's called set builder notation. And that's a larger group of numbers here. And set A here is just -1, 0, 1, 2. Set B is 1, 2, 3, 4. So the union of sets A and B would be -1, 0, 1, 2, and then 1 and 2 are already listed, and then 3 and 4. So -1, 0, 1, 2, 3, and 4. And typically when we are listing out elements in set in roster method, you'll use these little squiggly brackets here. The way you see it written here is how I would want to see it on a quiz or exam. The intersection of sets A and B is what they have in common. Well, both sets have the number 1 and both sets have the number 2, and that's it. So that's the intersection of set A and B. Now it's a little bit more challenging when we're looking at an interval written in an inequality, but it's not much harder. What I suggest doing is graphing them both out on a number line. Now nowhere in the instructions does it tell you to do that, but I think it's a helpful visual. So set A is x less than or equal to 5. So the number 5 has the equal to symbol, so we will use a closed dot on 5. And then we want all the values less than 5. So that would be this side of 5. Set B is x greater than -3, but less than or equal to 8. So -3 and 8. And this has the less than or equal to, so it will have a closed dot, but this is just strictly greater than, so it will be an open dot. And it's all the x values between these two, so in between -3 and 8. So if I want the union, a union B, that would be like squishing these two together. And wherever it's shaded, if it's overlapped or just shaded on one of them, that doesn't matter. So if you imagine just squishing these two number lines together, it would be shaded everywhere to 8. That would be a closed dot at 8. It's closed dot here, and everything less than 8. Now typically we will write our answers in interval notation. So the way we would write this is, if you think about this being a number line, this is -infinity all the way to +infinity. So this would be all the way, since it goes forever and ever this way, -infinity all the way to 8. This is a closed dot, so we will use a bracket. And for those inequalities, and whether we use parentheses or not, one thing you kind of want to make a note of here is that positive or negative infinity always uses parentheses. Okay, so they will never use the brackets like this. Infinity will always be parentheses. Let's practice another one of those. Here I have set A, and it's x greater than -2. So again, oh, you know what? I didn't do the intersection. Let's go back to that one. A intersect B. Now, this is where I want what the two sets have in common. So I want the area where they are both shaded. So that would be this area here where they're both shaded. But notice that at -3, this one is not shaded there, even though it is shaded here. So that's not part of our answer. So if I were to graph that out, that overlapping part is from -3 to 5. And 5, it's shaded on both of them, so I'll use a closed dot. 3 is not shaded on both of them, so it'll be an open dot, and then it's everywhere between. So that would be the intersection of those two sets. That would be a parenthesis at -3 and a closed dot here on 5, so a bracket. One thing I will suggest in this class, if you are watching the videos and you have a question, I suggest either having a sticky note or maybe somewhere off into the margin here, writing your question down. And then when you come to class, you have those questions written down because you might not remember them when you get to class. So write your questions down as you watch the video and then come to class ready to ask those questions since you'll have them written down. If you don't write them down, I know myself, I would definitely forget. So I know most people would probably forget and not remember what questions they had. So. Next one, x is greater than -2, so -2, open dot because it just has that greater than, not the greater than or equal to, and it's all the x values bigger than -2, so that would be bigger over here. B is -10 to 12, so -10 and 12, and you'll notice I'm not being precise, like exactly perfect with lining up my numbers here, but I know -10 is less than -2, so I want to make sure it's to the left of -2. 12 is obviously bigger than -2, so it's to the right of -2. -10 should be an open dot, and 12 should be a closed dot, and it's all the x values between. So those are A and B. A union B would just be squishing those two together. So if I were to squish these together, this one goes off forever to infinity, and we start here at -10. So -10, open dot there because it's open here, and then all the way to infinity. So that would be -10 using a parenthesis because open dot all the way to infinity. A intersect B is the overlapping. So if you look at these two, and again, this is why I really find it helpful to actually graph them, even though nowhere in the instructions did it tell you to graph. So from -2 to 12 is kind of our overlapping area here. It's not shaded at -2, so we would have an open dot there, but it is shaded at 12 on both of them. So from -2 to 12, closed dot, open dot, everywhere in between, -2 to 12, and a bracket on 12 is a closed dot. So that's the union and intersection of sets. What we're going to practice now is converting between different forms. So here it says to write this set in set builder notation. It's currently in interval notation. So -infinity to 0, -infinity all the way to 0, has a bracket at 0, so that would be a closed dot. And again, nowhere did it tell me to graph. I just think this is a helpful visual. So the way we could write this in set builder notation, remember it has a little squiggly bracket, x, and that vertical line, which means x such that, meaning x, and then we're going to describe x, and it's all the values less than 0. So we have x less than or equal to 0. Here we have -3 to 2. They both have parentheses, so both open dots. It's all the values between. So x such that x is between -3 and 2. They're both open dots, so there's no lines underneath either of those inequalities, and that's writing it in set builder notation. If I want to write this in given set builder notation and want to write it in interval notation, here it asks me to graph and to write in interval notation, so it is explicitly telling me to graph this. So we've kind of already practiced this here. -2 and 1, open dot at -2, closed dot at 1, and all the values between. Writing that in interval notation would be -2 to 1. And then the next one here, x is less than 4, so 4, and all the values less than that. And it has a line underneath it, so it'll be a closed dot. And that would be negative infinity all the way until 4, and a bracket 4 because it's a closed dot. Now we're going to shift gears just a little bit and talk about exponents and exponent rules. So here, when we're talking about exponents, we're talking about if I have something here, this is the exponent, 4 is the exponent, and 7 is the exponent here. Okay, so we're not going to talk about polynomials quite yet, but we are going to talk about exponent rules. And if you think about playing a game, anytime you're playing a game, you want to know what the rules are for the game. So if I have a bunch of exponent rules, I kind of think about these as the rules for the game of simplifying exponential expressions. So the first rule here is if I have a to some power and a to some power and they're being multiplied, you add those exponents together. So for example, if I have x to the 5th power times x to the 3rd power, that would be x to the 8th power, adding them together. The way that works is that x to the 5th power is really x times x times x times x times x. And then x to the 3rd power is really x times x times x. And all of those being multiplied would be x to the 8th power. That's why that works that way. Now it's easy to confuse that with this next rule. Here, if I have a to some power and then that whole thing raised to another power, there's no another a here. This whole thing is being raised to another power again. Then you multiply them. So if I had, let's say, x squared to the 3rd power. What that's saying is I have x squared 3 times. Well, x squared times x squared times x squared. But each of those x squareds is x times x, and x times x, and x times x. That would be x to the 6th power, which is 2 times 3. Now I'm showing you all of the why here, why this works the way it does. You don't have to do that every time if you don't need it. If you need this and this is a helpful tool for you, feel free to show that work. But if you're able to go from x to the 5th power times x to the 3rd power is x to the 8th power, or if you're able to go from x squared to the 3rd power to x to the 6th power, that's totally fine. The next one here is division, and it works really similarly to the multiplication. Here we add the exponents, here we subtract them. So if I have, let's say, y to the 7th power over y to the 4th power, 7 minus 4 is 3. The way you work that out is y to the 7th is 7 y's. And 4 y's on bottom. And 4 of those cancel out, and we're left with 3 on top. Now, everybody's favorite exponential rule is a to the 0 power equals 1. That means anything to the 0 power is just equal to 1. I could have 5,000 to the 0 power, and that's just equal to 1. I could have x squared y cubed z to the 7th times 8, whatever I want to put in there, all to the 0 power is just equal to 1. Okay. Now the next rule gets into negative exponents, and what we're looking at here is, what you want to remember is that negative exponents move. And when they move, they become positive. So negative exponents move and become positive. So if I have a to the negative n power, it's going to move to the bottom and become a positive n. If I have a negative in the bottom, it moves to the top and becomes positive. So if I have, let's say, 5 over x to the negative 3, that's going to move to the top and become positive. So that would be 5x. Actually, really, I should have put this example here to the 3rd. So I should have done this example for this one. I'll do one like this here. If I have, let's say, 3y to the negative 2 power, this negative 2 is just on the y. It's not on the 3. If there were parentheses around this whole thing, then the 3 would also move. But the negative 2 is just on the y. So this becomes 3 over y to the positive 2 power. These last two rules are distributing exponents. So this exponent here goes onto the a and onto the b. So if I have, let's say, xy to the third power, that becomes x cubed, y cubed. Same thing with division, as long as those parentheses are around the whole fraction. If I have something raised to a power, then that becomes, let's say I have x over 5 squared. That power goes onto both of those, and that becomes x squared over 25, which is 5 squared. So what we're going to do now is practice some of these exponential rules. And that'll bring us to the end of this second video. So this first example here, I have negative 2 times a times b to the fourth power times negative 3 times a squared times b to the fourth power. And in this example here, if you think about numbers, if I have the numbers, let's say 1 times 2 times 3 times 4 times 5. Well, if I do them in that order, or if I change the order, if I do 4 times 2 times 3 times 5 times 1, or I could change the order again, 2 times 5 times 1 times 3 times 4. All of those are going to give me the same answer. So these are all being multiplied. There's no exponents being applied to them. I can reorder them however I want. So I can do negative 2 times negative 3 first, and then I can do a times a squared, and b to the fourth power times b to the fourth power. Well, negative 2 times negative 3 is 6. A times a squared is a cubed, and b to the fourth and b to the fourth is b to the eighth. And that's it. Here, I have a set of parentheses around this whole thing. There's no exponent for me to distribute. I just need to reduce this fraction. Well, the m's will reduce with each other, the n's will reduce with each other, and the numbers will reduce with each other. 18 and 27 have a common factor of 9. 18 divided by 9 is 2, and 27 divided by 9 is 3. Negative 2 and 3. And here I have a negative exponent. That m to the negative 3 is going to need to move to the bottom and become positive. So m to the positive 3. Here I have an m to the 0, and that is just 1. Well, 1 times 3 is still just 3 on the bottom. Here I have n to the 5th and n to the 4th. Well, if I write out all those n's, and let me just do that here below, n, that's 5 on top, 4 on bottom. 4 of those cancel, and I'm left with 1 n on top. So my answer is negative 2n over 3m cubed. We'll do 2 more, and then we'll stop here for this video. So this next one now has an exponent out here that needs to be distributed, and these parentheses cover both the top and the bottom of the fraction. So this negative 2 is going to go on every single term here. So I have negative 16 to the negative 2 power. I have m to the third to the negative 2 power. I have n to the 7th to the negative 2 power. On the bottom, I have 8 to the negative 2 power. I have m to the 5th to the negative 2 power. I have n to the negative 2 to the negative 2 power. So all I did here was distribute this negative 2 onto all of these pieces. Now, I need to simplify these, and then anything that's still negative is going to have to move. Now, it's not about the number being negative. See this negative 16 here? The number is okay to be negative. It's if you have a negative exponent that it moves. So Here I have negative 16 to the negative 2. I'm just going to leave it as that for now. M to the third to the negative 2, we multiply these, so that becomes M to the negative 6, N to the negative 14, 8 to the negative 2, M to the negative 10, and N, and this is negative 2 times negative 2, and that becomes positive 4. So again, anything with a negative exponent is going to move. So this term is going to move down. This term is going to move down. This term is going to move down because they all have negative exponents. This term has a negative exponent, so it's going to move up. This term has a negative exponent, so it's going to move up. This has a positive exponent, so it's not going to move. So from here, that n to the fourth, I'm just going to keep there because it's not moving. The rest of these, I'm going to move them, and after I move them, I cross them out so that I don't do it twice. I know it's taken care of. So negative 16 to the negative 2 power moves down and becomes a positive exponent. The number does not become positive. The exponent is what becomes positive. Our 8 here to the negative 2 power moves up and becomes a positive exponent. M to the negative 6 moves down and becomes a positive exponent. N to the negative 14 moves down and becomes a positive exponent. M to the negative 10 moves up and becomes a positive exponent. And the n to the fourth I took care of already. From here, I need to combine the n's, I need to reduce the m's, and I need to reduce the 8 and the 16. Now, 8 squared is 64, and 16 squared is, I think, 256. Yep. So, I'm going to move this all the way over here. 8 squared is 64, and 256. And then m to the 6th and m to the 10th. Well, 6 of those will cancel, and I'll be left with 4 on top. So I have m to the 4th on top. And then n to the 14 and n to the 4, that gives me a total of 18. So n to the 18th power. Now, I can reduce 64 and 256, and that reduces to 1 on top and 4 on bottom. So I have m to the 4th over 4n to the 18th power. One more problem in this video. Here I have 2 sets of parentheses here, and each one of them has an exponent that's going to be distributed to each term inside that set of parentheses. So the first thing I need to do is distribute those exponents. So that becomes negative 3 to the negative 3 power, x to the 5th to the negative 3 power, and y to the negative 3 power. And then here I have 6 squared, x squared, and y to the 4th squared. Now, as you get more comfortable with this, you might not need to write out this step. You might be able to go to the next step from the very beginning. That's perfectly fine. Here I have negative 3 to the negative 3 power. X to the 5th to the negative 3rd becomes x to the negative 15th. And then y to the negative 3rd is just y to the negative 3. And then 6 squared is 36. And then x squared is x to the 4th and y to the 8th. Now I have some negative exponents, and just like the last problem, those need to move to the bottom. So even though I didn't have a fraction before, these still need to move to the bottom and become positive. So that becomes negative 3 to the positive 3 power. Again, the number doesn't change, it's just the exponent that changes. X to the positive 15 and y to the positive 3. So I took care of those 3. And then 36, and these are positive. They're not going to move. They are already up top. They'll stay up top. From here, I just need to reduce. Well, x 4x's on top and 15 on bottom. 4 of those will cancel out, and I'll be left with 11 on bottom. 8y's on top and 3 on bottom. 3 will cancel, I'll be left with 5 on top. So 36y to the 5th. Negative 3 to the 3rd power is negative 27, and x to the 11th. 36 and 27 are both divisible by 9. 36 divided by 9 is 4, and 27 divided by 9 is 3. So my final answer then is negative 4y to the 5th over 3x to the 11th. And you might be wondering why I moved that negative. It really doesn't matter. I could leave it on the bottom with the 3, or it could become on top. It's the same value. It's the fact that the fraction is negative. Okay. I'll go ahead and end part 2 here. We'll pick up with part 3 and radicals and rational exponents.